Hello all, it's been a long time since we have continued our classes. So last time I think we have ended with physics, so now we are resuming with physics, the next chapter just called. One second everyone. Okay, physics, we are going to continue with AI etc. Physics. The next chapter we are going to focus today is Newton's laws of motion. In this chapter also, we're going to discuss about important concepts as well as formula revision. Okay, so let's start on with the class. Okay, so firstly we are going to discuss about inertia. So I'll just give a small explanation of what inertia is. It is the property of an object by virtue of which it cannot change its state of rest or of uniform motion along a straight line on its own is called inertia. Greater the mass of a body, greater will be the inertia. You can note this point down. Greater the mass of a body implies greater the inertia. Okay. Also, inertia is of three types. First is inertia of rest. It is defined as the tendency of a body to remain in its position of rest. That is, a body at rest remains at rest and cannot start moving on its own. The next is inertia of motion. This is defined as the tendency of a body to remain in its states of uniform motion along a straight line. That is, a body in uniform motion can neither gets accelerated nor gets retarded on its own. Also, it cannot stop on its own. The last one is inertia of direction. This means that it is defined as the inability of a body to change by itself its direction of motion. Okay, so this is all about inertia. The next topic we are going to learn is about force. We all know what force is since we have been studying from first standard onwards. Force is a push or pull which changes or tries to change the state of rest, the state of uniform motion, size or shape of a body. SI unit is Newton. Right. Dimensional formula is dimensional formula is ml t raised to minus 2. Okay. Force can be categorized into two types. First is contact forces. Contact forces. Contact forces examples are frictional force, tensional force, spring force, normal force are contact forces. We can give a bracket like this. Frictional force, tensional force, spring force, normal force, etc. Okay, normal force. The second one is distant forces. Distant forces are also called field forces. Okay, distant forces. Everyone, please note these points down because this chapter is focused more on theory as well as formulas. Distant force. Examples of these force can be varying as electrostatic force, electrostatic, electrostatic force, gravitational force, magnetic force. Okay, they are distance forces. The next force we need to know is impulsive force. Impulsive force. It is a force which acts on a body for a short interval of time and produces a large change in momentum. Okay, just know its definition. The next topic we need to know is linear momentum. Okay, linear momentum. It is the total amount of motion present in a body is called momentum. Linear momentum of a body is equal to the product of its mass and velocity. It is denoted by P, which is equal to P equal to M into V, that is M mass, V velocity. Its SI unit is kilogram meter per second. Okay, and dimensional formula denoting it by df ml t raised to minus 1. Okay, it is a vector quantity. Vector quantity, and its direction is in the direction of velocity of the body. Okay, now the next thing we need to know is law of conservation of linear momentum. Law of conservation of linear momentum. Okay, if no external forces acts on a system, then its total linear momentum remains conserved. Linear momentum depends on the frame of reference, but law of conservation of linear momentum is independent from frame of reference. Newton's laws of motion are valid only in inertial frame of reference. You can write as a point. Newton's laws of motion are valid only in inertial frame of reference. Okay, let us go to the next topic. Okay, the next topic is impulse. Impulse. The product of impulsive force and time for which it acts is called impulse. That is, impulse is equal to force into time. Okay, which is defined as change in momentum. Change in momentum. Okay, its SI unit is Newton second or kilogram meter per second, and its dimensional formula is ml t raised to minus 1. Okay, impulse is also equal to change in momentum of an object. It is a vector quantity. Vector quantity, and its direction is in the direction of force. Okay, you can note an entrance point. Total impulse for the force applied during period T1 to T2 equal to area under the FT curve equal to area under the FT curve from T1 to T2. Okay, please note down this also. Okay, it's just in reference point. You will understand more when we do problems. Okay, now let's move on to the next topic. Okay, the next topic is Newton's laws of motion. Let us go through each laws one by one. First one is Newton's first law of motion. Okay. A body continues to be in its state of rest or an uniform motion along a straight line unless an external force is applied on it. This law is also called law of inertia. Inertia. Okay. Examples can be like when a carpet or a blanket is beaten with a stick, then the dust particles separate out from it. Can be one example. The second example can be like if a moving vehicle suddenly stops, then the passengers inside the vehicle bend outward. Okay. The next one is Newton's second law of motion. The rate of change of linear momentum is proportional to the applied force, and change in momentum takes place in the direction of the applied force. That is, mathematically speaking, applied force F is proportional to the rate of change of momentum, that is dp by dt. Okay, we know that P is equal to mv. Okay, I want to remove this proportionality, so I'm referring it as a constant k into d by dt of mv. Okay, here k is the constant of proportionality. K. Okay, here k is constant of proportionality. Here k is the constant of proportionality. Its value is 1 in SI and CG system. So F is equal to m into dv by dt. Okay, the value of k is equal to 1. That's how I got this equation. In SI system and CG system, the value of k equal to 1. F is equal to m into dv by dt. We know what is dv by dt. What is it? Is equal to m into a. Okay. The second law of motion is a vector law. It's a vector law. It is equivalent to three equations, one for each component for the vectors. Since it is also called, this law is also called vector law, it is equivalent to three equations. I'll write these three equations one by one. One is represented as fx. Fx is equal to dpx by dt is equal to m into ax. Okay, that is force in x component. Force in y component is equal to dpy by dt, which is equal to m into ay. Okay, f z is equal to dpz by dt, which is equal to m into az. Okay, I'll say some examples related to second law of motion. Examples: it is easier for a strong adult to push a full shopping cart than it is for a baby to push the same cart. This is depending on the net force acting on the object. Second example can be, it is easier for a person to push an empty shopping cart than a full one, because this is depending on the mass of the object. Okay, now let us go to the next law of motion, which is the third law. Third one, Newton's third law of motion. Third law of motion. For every action, there is an equal and opposite reaction, and both acts on two different bodies. Let's say we on body one there is a force exerted. Okay, and let's say there's body two there's a force exerted. Opposite reaction force. This is in force one I gave an action. I got a reaction from force two. That is this is force one F1 2. This will be F2 1. Okay, sorry F not like this F2 1. Okay, F2 1. Okay, F2 1. Okay, so generally speaking, we can say that F12 is equal to minus F21. That is, for every action, there's an equal and opposite reaction. Like that concept. Okay, examples. Examples can be swimming becomes possible because of third law of motion. Jumping of a man from a boat onto a bank of river. Jerk is produced in a gun when bullet is fired from it. Pulling of cart by a horse. You can note down this special entrance point, which can be asked in A86 exams. Newton's second law of motion. Newton's second law of motion. Second law of motion is called real law of motion. Real law of motion because first and third law of motion third laws of motion can be obtained from it. Obtained from it. Okay, good. The next one we are going to learn is rocket. Rocket. A rocket is an example of variable mass following law of conservation of momentum. Thrust on the rocket at any instant is given by thrust is same as force. Okay, thrust on rocket is given by F is equal to minus U into dm by dt. Okay, where U is the exhaust speed of the burnt gas, dm by dt, d capital M by dt is the rate of combustion of fuel. Combustion of fuel. Okay, and the velocity of rocket at any instant is given by V equal to V0 plus U log capital M0 by capital M to the base E. Okay, where V0 is the initial velocity of the rocket, M0 is the initial mass of the rocket, M is the present mass of the rocket. Okay, all these are important formulas. If effect of gravity is taken into account, okay, you can draw a small box here. Okay. if effect of gravity is taken into account, then the equation becomes like this: v is equal to v0 plus u log m0 by m to the base e minus gt. Okay, it's an important equation. Note it down, guys. Asked in many entrance exams, so it will ask in next 86 exam. Okay, let us now let us proceed with the next topic. The next topic is called equilibrium of a particle. Okay, so when the vector sum of the forces acting on a body is zero, then the body is said to be in equilibrium. Okay, let's say it's a body. Okay, here two forces are acting on it. One is F1 and other is F2. Okay, if this body is equilibrium, then the forces F1 and F2, sum of the forces F1 and F2 must be zero. That is, if the two forces F1 and F2 is acting on this particle O, then they will be in equilibrium only if F1 plus F2 is equal to 0 implies they are in equilibrium. Okay, equilibrium. Okay, the next one is an important theorem which is called Lami's theorem. This is an important theorem in which you guys have studied in 8th standard, 6th standard and all. Okay, it states that if three forces acting on a particle are in equilibrium, then each force is proportional to the sine of the angle between the other two forces. Let's say we have a particle called O. We have the first force acting on it, F1, second force acting on it, F2, third force acting on it, F3. Okay, F3. Okay, if alpha is the angle opposite to F1 alpha, beta is the angle opposite to F2 here, that is beta here, and gamma is the angle opposite to F3, that is gamma here. Then Lami's theorem states that F1 by sine alpha equal to F2 by sine beta equal to F3 by sine gamma. Okay, this is Lami's theorem. It's an important equation, please note it down. Okay, now we are going to learn about the common forces in mechanics. Okay, some of the common forces that we come across in mechanics are given as: first one is weight, which is denoted as W. Okay, it is a field force. It is the force with which a body is pulled towards the center of the earth due to gravity. It has the magnitude mg, where m is the mass of the body and g is the acceleration due to gravity. That is, weight W is equal to mg. Okay, next one is normal reaction. Normal reaction. It is a contact force. It is the force between two surfaces in contact which is always perpendicular to the surfaces in contact. It is denoted by R. Okay. Next one is tension. Tension force always pulls a body. Tension is a reactive force, it is not an active force. Tension across a massless pulley or a frictionless pulley remains constant. Rope becomes slack when tension force becomes zero. Okay. Okay. The next one we are going to learn is friction. Friction. A force acting on a point of contact of the objects which opposes the relative motion is called friction. That is, friction is always opposite to force. That's what it means. It acts parallel to the contact surfaces. Frictional forces are produced due to intermolecular interactions acting between the molecules of the bodies in contact. Friction is of three types. Okay, first one is three types. Okay, first one is static friction. It is an opposing force which comes into play when one body tends to move over the surface of the other body but actual motion is not taking place. Static friction is a self-adjusting force which increases as the applied force is increased. Static friction opposes impending motion. Okay. Second one is limiting friction. Limiting friction. It is the maximum value of static friction when body is at the verge of starting motion. That is, limiting friction is given by limiting friction, comma, Fs max equal to mu L into R. Okay. Mu L into R. Okay. Where mu L is the coefficient of limiting friction. Coefficient of limiting friction. Okay. Coefficient of limiting friction, and R is the normal reaction. Limiting friction do not depend on area of contact surfaces but depends on their nature, that is smoothness or roughness. Let's say we have an object. This is an object. If a force F is applied, okay, then the limiting friction will be in the opposite direction to here, that is Fs max. Okay. The next thing we have to know is angle of friction. Angle of friction. It is the angle which the resultant of the force of the limiting friction and the normal reaction makes with the direction of normal reaction. Okay, that is mu L equal to tan theta, where theta is the angle of friction. The next one is angle of mu L is equal to tan theta. Okay. The next one is angle of repose or angle of sliding. Angle of sliding. It is the minimum angle of inclination of a plane with the horizontal such that a body placed on it just begins to slide down. If angle of repose is alpha, if angle of repose is denoted as alpha and the coefficient of limiting friction is mu L, okay, then mu L is equal to tan alpha. This is the relation between these two terms. Okay. The next one we are going to learn is third type, the last type of friction. This is called kinetic friction. It is an opposing force that comes into existence when one object is actually moving over the surface of other object. Okay, so kinetic friction is denoted as Fk. Fk equal to mu k into R, where mu k is the coefficient of kinetic friction. Coefficient of kinetic friction. Okay. R is the normal reaction. Kinetic friction is of two types. Sliding friction and rolling friction. Sliding friction and rolling friction. Okay. A special note: if rolling friction is less than sliding friction, therefore it is easier to roll a body than to slide. Therefore implies easier to roll a body than to slide. Okay. Okay. Next one, we are going to learn about motion on a rough inclined plane. Okay, let me draw an inclined plane first of all. Okay, okay, so straight lines. Okay, this is theta. Okay, I'm going to keep an object here. Okay, gravity will be acting downwards. That is g, yeah, weight of this object. Yeah, g. Okay, this is the normal reaction will be acting perpendicular to the surface of contact. So this will be the normal reaction system to be a straight line. Okay. Okay. Normal reaction opposite will be okay. This there is an angle. This is if this is theta, this will also be theta. So what will be this the other side? So this will be mg cos theta. Okay. And so this is the normal reaction R. Okay. Since it is going down, if we place an object in an inclined plane, it will be going down. So we can say that the direction of force is in this direction. If force is along this direction, we can say the friction is along this opposite direction, right? So if this is mg cos theta, what will be this? This will be mg sin theta, right? Mg sin theta. Okay. This is just a rough figure, guys. Okay. When an object moves along an inclined plane, then different forces act on it, like normal reaction of plane, frictional force acting in opposite direction of motion, etc. Different relations of motion are given below. The normal reaction of plane is given by R equal to, what is it? R equal to mg cos theta. This type mg cos theta. Okay. The net force acting downward on the block is F equal to downward mg sin theta. There is also an opposing friction, so minus F. If the friction is along the same, we can give plus. Since the friction is opposite direction, so minus. Okay. The acceleration on inclined plane is given by A equal to g into sin theta minus mu cos theta. Just know how it came, how the equation came. Write the equation here. Okay. E is equal to acceleration on the inclined plane. Just by heart this equation, A is equal to g into sin theta minus mu cos theta. Okay. Okay, so now we are moving on to the last concept of this chapter, apparent weight in a lift. apparent weight in a lift. Okay, so first condition, case 1. When lift is at rest or moving with constant speed or velocity, or moving with constant speed. Okay, so the figure will be like this. This will be the lift, lift. This will be the object is at the left. Okay, this the apparent weight R. Okay, this will be the actual weight, that is mg. Okay, actual weight which is same. This is actual, mg is the actual weight, R is the apparent weight. Okay, lift is at rest or moving with a constant speed or velocity, that is v equal to 0, that is rest, condition for rest, or v is equal to constant, that is constant speed or velocity. Okay, in this case the apparent weight is denoted as R. Okay, R. Okay, R equal to mg. Why? When the lift is at rest or moving with constant speed, that is the weighing machine will read the actual weight, that is the apparent weight will be equal to the actual weight, or the weighing machine will read the actual weight. Now let us go to second case. Okay, case 2. Okay, case 2 is that when lift is accelerating upward, lift is accelerating upward, then the figure will be like this. This will be the lift, this will be the particle, this will be the apparent weight R, I'm denoting this R1, and this will be the actual weight mg. Okay, in this case the lift is accelerated upward, which is moving upward with the acceleration a, R1 equal to m into g plus a. Okay, since it's going upward, R1 equal to m into g plus a, so the weighing machine will read the apparent weight which is more than the actual weight. Okay, let us go to the next case. Case 3. When the lift is accelerating downward, lift is accelerating downward. Okay, then the apparent weight is given by, let me draw the figure. This will be the lift, this will be the particle, this will be denoting it as all reaction as R2, apparent weight is R2, actual weight is mg, then the apparent weight is given by R2 is equal to, lift is moving down with constant acceleration a, R2 is equal to m into g minus a. Okay, so here the weighing machine will read the apparent weight which is less than the actual weight. Then the last case, case 4. When the lift is falling freely under gravity, lift is falling freely under gravity. In this case the apparent weight of the body R equal to 0. Okay, in this case apparent weight of the body becomes 0. So these are the important things that we need to study in this chapter, Newton's laws of motion. I hope all of you understood. There are also some of the few formulas which were asked in JEE means exam, NDA exams and all, but those type of level questions I haven't seen in ETC exams yet. So when we discuss problems, if we are coming across any new formulas which haven't been covered in the concept and formula class, I will surely explain those formulas and note it down in the discussion class, that is practice problems classes. I hope all of you understand all of the concepts taught today, and there was a huge gap between the classes. So don't worry, classes will resume soon as always. So thank you, have a nice day.